Hi, and welcome to Radicals and Systems, Day 3. Today we're getting rid of radicals, and we're going to talk about systems of equations in 3 variables, but we're going to start out with reviewing solving systems of equations with 2 equations with 2 unknowns. I have here 2x plus 3y equals 7 over 2x plus y equals 3. My goal is to eliminate either x or y. I need to get one of them to cancel out. Right now, both of my x's are positive. So if I were to multiply one of my equations, it doesn't matter which one, by -1, I can eliminate my x's. So when I do that, I have 2x plus 3y equals 7. Here, I will end up with negative 2x minus y equals negative 3. So there, when I add my 2 equations together, my x's cancel out. 3y minus y is 2y, and 7 minus 3 is 4. Divide by 2, so y is equal to 2. Once I find y, I have to go back and find x, and it doesn't matter which equation I use. 2x plus 3 times y is 2 equals 7. So 2x plus 6 equals 7. Subtract the 6 from both sides. So 2x equals 1. Divide by 2. X equals 1/2. Now we can take and write these as an ordered pair, because if we were doing these graphically, the solution would be where the 2 graphs intersect, and it would be at a point. Alright, for number 2, it's the same idea, except nothing will cancel out right away. So I need to multiply again. I'm going to get the y's to cancel out. And I'm going to multiply the value equation by 2. So I will have 5x minus 2y equals 4 over, negative 4x plus 2y equals 4. So my y's cancel out, and I just have x equals 8. So let's find y. 5 times 8 minus 2y equals 4. So 40 minus 2y equals 4. Subtract 40. So negative 2y equals negative 36. Divide by negative 2. So y equals 18. So my ordered pair this time is 8 and 18. Now notice I'm not making you do the checks for these. If you really wanted to, you could check them both, but you don't need to. Oh no, not one of these again. Scientist wants to create 120 milliliters of a solution that is 30% acidic. To create the solution, she has access to a 20% solution and a 45% solution. How many milliliters of each solution should she combine to create a 30% solution? All right, I've already shown you how to do this problem a different way. Well, here we go again. New way, new method. This time we're going to use 2 equations with 2 unknowns. And we're going to do that x equal the 20% solution, and we're going to y equal the 45% solution. And I know that I have 2 different kinds of solution and I have a total of 120 unknowns. So that means that x plus y has to equal 120. And I also know that I have 20% of x and 45% of y to give me 40. 30% solution, so it would be 0.3 times 120. And 0.3 times 120, just so you know it, is 36. Now, I need to get something to go away. Nothing cancel out. So, I'm just going to choose to eliminate x. I could choose to eliminate y. I've got negative 0.2. 0 or negative 0.2. So I have negative 0.20 minus, or x, sorry, minus 0.20y equals, let's see here, negative 24. And then bring my 0.20x over plus my 0.45y equals 36. X's are going to cancel out, and I'm going to get 0.25y equals 12. Divide by 0.25. And y will be equal to 48. So then I'm going to go back over here to my original equation, x plus y equals 120. So x plus 48 equals 120. Subtract the 48. So x equals 72. So therefore, since x was 72, we'd have 72 milliliters of the 20% solution and 48 milliliters of the 45% solution. So yet another way to do the same problem we were doing the other day. All right, this is where life gets a little bit more tricky. Determine the values for x, y, and z. So now I have 3 equations with 3 unknowns. I think it's best if we number the equations. This would be 1, this would be 2, this would be 3. We can only work with 2 equations at a time. I'm looking at my equations. 2 and 3 are right next to each other. And so I picked those 2 to work with. So equations 2. So 2 is 4x minus 5 minus z equals -1. And 3 was x plus 4y plus z equals 12. My z's are also guys, we can't remove it. So I'll get 5x plus 3y equals 11. Now I'm going to take equations 1 and 2 and do the same thing. So equation 1 is 2x plus 3y minus z equals 5. And then 2 was 4x minus y minus z equals -1. Now nothing immediately will cancel out. Okay, so I'm going to multiply this equation by -1. And I will get 2x plus 3y plus 3y minus z equals 5. Alright, when I multiply the bottom one by -1, I get negative 4x plus y plus z equals positive 1. So the z's cancel out, and I have negative 2x plus 4y equals 6. So now I've created two more equations with just two unknowns. So we have equations, we'll call this one 4, and this one 5. So I'm going to take 4 and 5 and combine them. So I have 5x plus 3y equals 11, and then negative 2x plus 4y equals 6. Now when you look at these, there isn't obvious of one thing that can cancel out, so you're going to need to multiply both numerator and denominator. Wow, not a fraction, sorry. Multiply the first equation by one number and the second equation by another. So it's the only way you can get something to cancel out. I'm going to go for getting the x's to cancel out, because one's already positive, one's negative. So I'm going to multiply the top one by 2 and the bottom one by 5. So 10x plus 6y equals 22. That's my top equation. My bottom one is negative 10x plus 20y equals 30. Here my 10x's go away, so I have 26y equals 52. Divide by 26, so y equals 2. So that's just the start. Once I find y, then I have to go back and find x and z. Now, so to find x, I'm just going to use one of my equations that I found. I'm using equation 4. So 5x plus 3 times y is 2 equals 11. So 5x plus 6 equals 11. Subtract the 6 from both sides. So 5x equals 5. Divide by 5. X equals 1. Now I need to pick one of the equations, and I'm going to go back up, and I chose to work with equation number 1 and substitute in for x and y because that's what I have. So 2 times 1 plus 3 times 2 minus z equals 5. So 2 plus 6 minus z equals 5. And 2 plus 6 is 8 minus z equals 5. Subtract 8. So minus z equals negative 3. Divide by negative 1. So z equals positive 3. So that means I have 1, 2, and 3. And just like in the problems before, I can write them as an ordered pair. What happens is when you have 3 equations from 3 unknowns, you're actually working in 3-dimensional space. So you'd have 3 different lines intersecting at one point 3-dimensionally. Alright, first of all, there's a typo here. That x should not be an x, it should be an s. Now, I'm going to be very bold and number these for you and have you try this one. Well, I understand you might not get through the whole entire problem, but this one isn't as complicated as the other one, especially if you work with 1 and 3 to get started with. All right, good luck. For number 5, find the equation of the form y equals ax squared plus bx plus c that satisfies the points 1, 6, 3, 20, and negative 2, 15. We kind of did something like this way back in the beginning of the year. But remember, these are all points, x and y. So I need to create my equations. So my equations are going to come from substituting 6 for y and 1 for x into this equation. So 6 equals 1 squared is just 1, so a plus 1 times b is b plus c. And then for the next equation, y is 20, so it's 20 equals, if I put in 3 for x, 3 squared is 9, so it's 9a plus, if I put in 3 for x, it would be 3b plus c. And then for the last one, it would be 15 equals, if I put in negative 2 for x, negative 2 squared is 4, so 4a. If I put in negative 2 for x, we'll minus 2b plus c. So again, and 3, and we need to get to work. It doesn't matter which two we start with. None of them cancel out, but I can multiply any one of them by negative 1 and get the c's to cancel out. So I'm going to start with, we'll start with 1, 2 here. So if I multiply the first equation with negative 1, and I'll keep my second equation as it is. What's going to happen is I'm going to get negative 6 equals negative a minus b minus c, and then 20 equals 9a plus 3b plus c. So my c's will cancel, so 14 equals 8a plus 2b. Next, I'm going to work with equations 2 and 3. So for 2, it's 20 equals 9a plus 3b plus c, and 3 is 15 equals 4a minus 2b plus c. Again, multiply by -1. So I have 20 equals 9a plus 3b plus c, and negative 15 equals negative 4a plus 2b minus c. So again, the c's cancel out, and I have 5 equals 5a plus 5b. I created equations 4 and 5. Now I need to combine them. So let's see here. We have 14 equals 8a plus 2b, and 5 equals 5a plus 5b. Again, looking at them, nothing is really obvious that it's going to cancel out, but I'm going to eliminate my b's. So I'm going to multiply the top by 5 and the bottom by a negative 2. So that should give me 70 equals 40a plus 10b, and negative 10 equals negative 10a minus 10b. So my b's cancel out, and I have 60 equals 30a. So a equals 2. And once I get A to equal 2, then I can easily find B. So I would say 5 equals 5 times 2 plus 5B. So 5 equals 10 plus 5B. Subtract the 10, so negative 5 equals 5B. So B equals a negative 1. So I have A, I have B. Now I need to find C. And I think the easiest way to find C is to go use equation number 1. So I will have 6 equals 2 minus 1 plus C. So 6 equals 1 plus C. Subtract the 1, so 5 equals C. Okay, this time I wasn't looking for an actual ordered pair. I want the equation that goes there. So I'm just going to substitute in all my values for A, B, and C. So I equals 2x squared, because A was 2, B was minus 1, so minus x, and C is 5, so plus 5. So this is my final answer. All right, thank you.